Okay, so addition of vectors. So in addition of vectors, when we are at the triangle of addition. Okay, so what triangle of addition suggested? Suppose this is the one vector, say vector A, and you want to add this vector with say some vector B. So what is the addition? So what is the first step? First step is draw the first vector as it is there given, means with a given proper length and direction, means magnitude and direction. Okay, so I will draw it here. This is what the vector A. Okay, so then what second step? Second step is take the second vector and draw it in such a way that its tail coincide with head of the first vector. So you are not supposed to change any magnitude and direction. Okay, so you have to take the same direction over here. So this is what going to be a second vector, that is what vector B. Okay, so they are in same direction. This is also in this direction, then it is also in this direction, means in clockwise direction. Okay, so what will be the resultant? These two are what? These two are going to be a sides of triangle. Now join this one. Okay, so this became what? This became a triangle. Okay, so third side is going to be what? Third side is going to be a resultant, but in opposite order. So this is in clockwise. So if you take here, it is going to be wrong. So you have to take in anti-clockwise direction, means opposite order. Okay, so this is what your resultant. So resultant vector R equals to vector A plus vector B. Okay, this is what the simple addition of the vectors. Okay, so obviously your resultant is going to be here. Okay, so now we will see one important property of addition of the vectors. Suppose you are having one vector here. So this is one vector, say vector A, and add this vector with another vector which is say in this direction. Okay, so this is what vector B. Okay, so now if you add these two, what will happen? We'll see. I want to add vector A plus vector B. Okay, so how we can add? So take first vector as it is. So this is what the first vector. So A, so same magnitude, same direction it should be. So this is what the vector A. So vector B, so take as it is. So this is what going to be a vector B. Okay, yeah. So where is the resultant? So this is what vector A. This is what vector B. So after A, B is there. So A plus B. So resultant is going to be here. This is what the resultant. Okay, what is the direction? These two are in direction, means it should be in opposite direction. So this is what the opposite. So resultant R equals to A plus B, vector A plus vector B. Yeah. So you got the resultant. Now let me try add this in reverse order. What will happen if I add B plus A? Will B plus A give the same result as A plus B, or it will give the different? That I want to see. Okay. So now what I will do? I will write add B then A. Okay. B plus A I want. Okay. So B plus A means what? First you have to take B. So this is what vector B. So first step is draw the given vector as it is. So first you draw B as it is. So this is what B. So what I can write. So this is what going to be a vector B. What you want? You want B plus A. Okay, where is A? A is here. Okay. So now this A you should not draw here. Where you have to draw? What is the rule? The second vector should be drawn such that its tail join to head of first vector. Head of first vector is here. So join its tail to the head. So this is going to be your second vector. Okay. So this is what? A. This is what? B. So where is what is the resultant? So resultant is going to be this one. This is what the resultant. This is what R equals to A plus B, vector A plus vector B. So sorry, not vector A plus B. It should be vector b plus a. Okay, so vector b plus a, b plus a. Okay, so now you look at both the resultants. Magnitude, so it is going to be same. So same magnitude. Direction also same. This is also in this direction. So this is also in this direction. If you measure it with the help of scale, both the magnitudes are also going to be same. Then direction is also same. So both A plus B resultant of A plus B and B plus A have same magnitude and same direction. Okay, magnitude and same direction. Okay, so you can say vector A plus B is equals to vector B plus A. Vector A plus B is equals to vector B plus A. What is this? You must have studied this in your high school. This is what we call it as commutative law. Okay, that means the addition of vectors or vector addition holds for the commutative law. Okay, so I can write here. So commutative law. So commutative law holds for vector addition. Okay, so what is that? That is nothing but A plus B is equals to B plus A. A plus B is equals to B plus A. This is what the first property of the vector addition. Okay, so this is what properties of vector addition. Okay, so this is a very important property. What is that property? The commutative law holds for the whatever vector addition. Okay, they ask you what they will ask in your board exam. Write any one property and prove that. Okay, so what you have to write? You have to write for vector addition commutative law holds. Okay, that is what first property. So how we can prove? If they ask for 3 marks, you take A and B, two vectors. Okay, so first you have to write this one, then take the example. I am coming in reverse order. Okay, so take two vectors. First you take A plus B, then B plus A. If you get the same direction and magnitude, write just A plus B and B plus A have the same directions and magnitude. So that is why A plus B is equals to B plus A. So that is nothing but commutative law. Okay, so this is what how the vector addition is possible in case of commutative is possible in case of vector additions. Okay, so we will go with the second property. So before giving the statement, I will take the example. Okay, so then we will come to the statement what exactly it is. Okay, so for that we will take the example. So the first one, I will take one vector over here, that is what, say, vector A, and another vector I will take in this direction. So this is what, vector B. So I will take one more vector, so that is what I will take in this direction. Okay, vector C. So look at their magnitudes also. Magnitudes may not be same. Okay, so okay, so we have to add these three. Okay, so we can add it in many ways. So what I will do is, first I will add, simply I will show you how to add A plus B plus C. Okay, so simply A plus B plus C. So directly with the help of just drawing the vectors, we can get the answer. So what is that? So directly A plus B. So take A over here. Okay, A over here. Then where is B? This is vector A. This is vector B. Okay, but we don't know how to add 3 at a time. So that I am going to the next step. But as of now we know how to add only 2 vectors. So that is what I will do. I will break it. This I will make it as A plus B. Then I will add C. Okay. This I will make it as A plus B, then I will add C. So A plus B, where it will be the resultant? These two are in same direction, so resultant may be here, okay? So this is what the resultant. What is this? This is nothing but A plus B. This is nothing but A plus B. Now where is third vector? Third vector C is in this direction, okay? This is what vector C. So now forget about these two. This is in this direction, so C will be what? C will be here, okay? So this is what going to be your C. So length is little or less, okay? So length you can take it here. This is what your C. So now don't think of these things, okay? A plus B is there, so this is C. So where is your resultant? Your resultant is going to be here. This is what your resultant. So what is this? A plus B and C. Okay. So A plus B and C. So this is what A plus B plus C. What is the direction? This is in this direction. This should be in downward direction. Okay. So this is what A plus B plus C. Then you may ask, so why you are taking A plus B first, then C? Why not you take B plus C first, then why not you go for adding with A? That means, is it possible to add like this? A plus B plus C. Is it possible to add like this? We'll see what will happen. So take a B plus C. Where is B plus C? This is what B. So this is what the B. C. C is here. Okay. This is what the C. So length is little more. Okay. So this is vector C. This is vector B. What do you want? You want B plus C. So B plus C is this one. This is what B plus C. B plus C. So B plus C. Now what do you want to add? B plus C with A. So where is A? A is here. So A you have to draw like this. Okay. From here you can draw. What is this direction? Its direction is in downward direction. Okay. This direction is in downward. So a little cross, then this is what going to be your A. In this direction, they have given the direction. Okay. So this is what vector A. Now add these two. Forget about these two now. Add these two, B plus C and A. So that is A plus B plus C. So this is direction, this one is direction. So this is going to be what? This is going to be your resultant. What is the direction? Direction is downward. Okay. So this is what? Downward direction. So what is this one? This is nothing but A plus B plus C. Okay. So if you look at both the resultants, this resultant is what? This resultant is in this direction, and this resultant is also in this direction. This resultant is what? This is A plus B plus C. What about this one? This is A plus B plus C. Okay. However, we can add. You are getting what? You are getting the same result. That means both addition of A plus or resultant of, you can write resultant of vector A plus B plus C and vector A. So first you can take A plus B plus C, then vector A plus vector B plus C, resultant of A plus B plus C and A plus B plus C have same magnitude and direction. Same magnitude and direction. So what will happen? These two vectors are what? These two resultant vectors are going to be what? Going to be equal or going to be same. So that is what I can write. I can write it as so vector A plus B plus vector C, A plus B plus C is equals to vector A plus B plus C. Okay, so this is what holds for the what vector addition. So you must have again learned this one in your high school. What kind of law it is? This is the what is it? Associative law. So that is why. So associative law, associative law holds for vector addition. Okay, so this is what going to be a second property. This is what going to be a second property. What associative law suggests? Associative law suggests that A plus B plus C is equals to A plus B plus C. This is what we call it as the associative law. So totally we got two properties. What was the first property? So first property was commutative law holds. Commutative law holds for vector addition. So second property is associative law. Associative law also holds for what? For the vector addition. Okay. So I hope you got again how they will ask in your board exam. Prove that associative law holds for the vector addition. Okay. So what you have to do? You have to write the associative law first, then take the example vector A, B, C. Then you do this one A plus B first, A plus B first. Then you take C. Then you have to go with the B plus C first. Then take A, and you have to prove what by graphically. Okay. So what all these things are? We are doing it graphically. So how to find its magnitude of resultant? It's very simple. Take a scale and measure whatever magnitude you are getting. That is what the magnitude of the given vector. Okay. So that's why we call this as the what graphical methods. So from the graphical methods, we have proved that two properties holds for the what your vector addition, that is commutative law and associative law. So with one more important thing, that is if there are more number of vectors. Suppose you are having, say, if there are more than two vectors. So if you are having vector A here, so take a little better one. So this is what vector A. Then one more vector, say this is what vector B. Then take vector C one more. This is what vector. Take vector C like this. Okay. This is what vector C. Then take one more vector in this direction, vector D. So take one more maybe in this direction. So take it as vector E. If like this, so many number of vectors are there, then you cannot do like A plus B, then take resultant to add with C, then again resultant C, then add with D. No, it is not possible. So we can simply use one more method, that is called as polygon. Okay, we have to draw the polygon with the help of these things. Okay, so first just follow your triangle of addition. What is that? First draw the first vector as it is, then second vector tail should join with the head of first vector, then again third vector tail join with the head of second vector, like that. So we'll see over here. So suppose A, I will draw it here. This is what the vector A. So I am drawing vector A over here. Then take second vector, draw as it is in such a way that tail should come to head of first vector. So direction, look at the direction. Can I take from here? Okay. This is what the vector B. Okay. So what about C? So take and join it here. Tail should join with head. Okay. Means you should take in the same direction. Means it should be in same order. So this is what your vector C. Okay. This is what your vector C. So next vector D is here. So again tail should join with the head of the C, so it should go in this direction. Okay, so this is what your vector D. Okay, so next vector E is there. So tail should join with head of this one. So this is what going to be vector E. Okay. So these are the what given vectors. Vector A plus vector B plus vector C plus vector D plus vector E. Then where is the resultant? Very simple. What was the third step of triangle? The tail of first vector and head join the tail of first vector to the head of the last vector. So that will give the resultant in the opposite order. Okay. So now I will take tail of first vector, then head of last vector. Join, shall I write here? Join tail of first vector, join tail of first vector with or to head of last vector. Join tail of first vector to head of last vector. So this is what tail of first vector. This is what head of last vector. So join them. So this is what. So what about the direction? So these two are in what? In same direction. So resultant should be what? In opposite direction. So don't take in downward direction. Take it in upward direction. Okay. So opposite direction. Or taken in opposite order. Okay. So join tail of first vector to the head of last vector. So that will give you what? That will give you the resultant, but taken in the reverse order. Okay. So this is what your resultant. What is this? This is nothing but vector A plus vector B plus vector C plus vector D. This is what vector D plus vector E. This is what the result. Okay. So resultant is the line joining tail of first vector to the head of last vector. Okay. Taken in and take in opposite order or reverse order, opposite order. Okay. So that will give you what? That will give you the resultant. Okay. So that will give you the resultant. This is what we have done. Joining the tail of first vector to the head of last vector and taken in opposite order, that will give the resultant. Okay. So resultant is equals to vector A plus vector B plus vector C plus vector D plus vector E. So what is that resultant? Resultant is this one. This is what the resultant. This is what the resultant as it is. Okay. So this is how we can add the vectors when there are more than two vectors or three vectors like that. Okay. So then question may arise. You may ask, so why you are taking first A, then B, then C, then D? Why not you take B first, or either C first, or either D first? So like that also we will check whether we will get the same resultant or not. Okay. So suppose if I take C first. Okay. So if I take C first, what is the C? C is in this direction. Okay. This is what C. Then take B. B is going to be like this. Yeah. This is what B. This is what C. Then, sorry, this is what C and B. So then take A. So I will take A over here. This is what A. Then you can take D. So D, where is D? D is in this direction. This is what the D. Then again, or D. Then again, what about the E? E is there here in this direction. Okay. So this is what the E. Okay. So D a little crossed. So D is little crossed. Okay. So this is what your D, vector D. So this is what going to be your vector E. Okay. So I have taken in the different order. Okay. What order I have taken? I have taken C first, vector C first, then vector B, then vector A, then vector which one D I have taken, then vector E. Okay. So I have taken it in a different order. Okay, now what will be the resultant? What will be the resultant? So what how we can get the resultant? Resultant we will get as tail of first vector to head of last vector. So this is what going to be your resultant. Okay, this is what going to be your resultant. Yeah. It should join here properly. So less or more. What is the direction? Direction should be in opposite. So these are in same direction, so opposite. So it is almost a straight line. So it is going to be what? Almost a straight line. So resultant. This is what the resultant. So resultant is what? C plus B plus A plus D plus E is what? It is again like this only. This is what going to be result. Here also resultant is same. Here also resultant is same. That means whatever the order you can take, that doesn't matter. You will get the same result. Okay. So irrespective of order you have taken, you will get the same result. Okay. So that is why order of placement does not matter. So shall I write something? So order of placement does not matter. Order of placement. Order of placement does not matter. Okay, does not matter. So order of placement does not matter. This also you can give as a property. Okay, it may become a third property. Okay. So however order, you may take D first, you may take E first, or you may take B first, or you may take A first, whichever you can take first, whichever order you can follow. Again your final resultant is going to be what? Going to be same if you properly follow the vector law of additions. Okay. So this is what the what about the, you can say it as a third property, order of placement does not matter. And this is what, if they ask explain when there are more than two vectors, how we can add the vectors. So you can give this result. So this is what you can call it as a law of polygon of vector addition. Okay. So what is this? This is looking like a polygon. Okay. So polygon law of vector addition. Polygon law of vector addition. Okay. Vector addition. This is required when if there are more than two vectors. Okay. So this is required when if there are more than two vectors. Okay. So then what is required? Then required is polygon law of vector addition. So if they ask state and no need to state here. So just if they ask state also, you can explain. Just take the place the vectors in the same order from like tail of one vector joining the head of another vector. So at the end, so take the tail of join tail of first vector to the head of the last vector. So that will give the resultant. So like that, step by step you have to write if they ask. Okay. Usually polygon law they won't ask. They will ask the triangle, and one more is their parallelogram. But rarely for your other purpose you can take help of this one. Okay. If they ask the explain polygon law, you have to take this example and you can explain. Okay. So if you want to give the definition, or if you when all the vectors are taken as the sides of polygon, then resultant is the line joining tail of the first vector to the head of the last vector. That is what we call it as the polygon.